I'm Professor Indra Abeysekera. Let's look at how to increase causality in an experimental design. When independent variable has a relationship with a dependent variable, the relationship could be positive, negative, or the relationship could be nil, no relationship. So these three possibilities exist. But all we can conclude here is about the relationship. In an experimental design, we can extend this relationship into a causality. There are uncontrolled variables that can have an influence on this relationship. Because of these uncontrolled variables that are influencing this relationship, we cannot say that the independent variable causes the behavior or the change in the dependent variable. So the independent variable influences dependent variable. If that is the case, we call it the dependent variable is purely endogenous. That is, independent variable fully causes dependent variable. That means there are no uncontrolled variables influencing this relationship. But in real life, there are uncontrolled variables that are influencing a relationship. So therefore, often independent variable partially causes the dependent variable. So for us to find out whether an independent variable causes a dependent variable, we have to now control the uncontrolled variables. In these uncontrolled variables, some uncontrolled variables interferes with the relationship. There are uncontrolled variables that do not interfere with the relationship. Those that interfere with the relationship are called endogenous variable, and those do not we call the exogenous variables. So the uncontrolled variables have endogenous and exogenous variables. And for us to control, we can control the endogenous uncontrolled variables because exogenous uncontrolled variables have no influence on the relationship between independent variable and dependent variable. But from a practical perspective, it is time-consuming and difficult to identify endogenous uncontrolled variables for a given relationship between independent variable and dependent variable. So from a practical perspective, it is better to control all uncontrolled variables. But if we do know which uncontrolled variables are influencing this relationship, independent variable and dependent variable, then we can isolate those uncontrolled variables and use them and match those uncontrolled variables in the relationship that we are testing out. In an experiment situation, we may want to compare two groups in relation to the relationship, and in one group we can provide the uncontrolled variables, and in the other group we also provide the uncontrolled variables that are influencing the relationship. That's called matching. So that those uncontrolled variables that are influencing are matched in both groups. But if we don't know which uncontrolled variables are influencing, then we can randomly choose the individuals that are assigned to a group where we are going to look at the relationship of the independent variable by changing the independent variable, and the other group where we are not going to change the independent variable and then compare, but we randomly allocate, because in that way we randomly allocate the uncontrolled variable into the two groups. When conducting experiments, there are two aspects of validity. One is internal validity. That's the confidence placed in the cause and effect relationship. The other is external validity. That's the extent to which the findings from the experiments can be transferred to other settings. In experiments, we try to maximize the internal validity to increase the cause and effect relationship. When we want to maximize the internal validity, there are factors that can affect the validity that we need to take account of. There are 7 factors: history effect, maturation effect, testing effect, selection bias effect, mortality effect, statistical regression effect, and instrumentation effect. Let's take an example. Let's say a manager wants to test buy one, get one free promotion of a dairy product. First, history effect. During the experiments, media can announce the benefits of dairy products, and that can influence the findings of the experiments. Second, maturation effect. Experiment can provide favorable results due to passage of time when people have developed healthy habits to consume dairy products. Third, testing effect. Could be that the participants were exposed to a pre-test and their prior knowledge they bring into the testing phase. Fourth, selection bias. Selecting improper subjects. It could occur because the experiment offers incentives to lure volunteers. Fifth, mortality effect. While conducting the experiment, subjects can leave before the completion of the experiment. Sixth, statistical regression effect. It could be that in the experiment, some subjects have extreme scores. Some consume extremely low amount of dairy products and others consume excessively high amount of dairy products. Seventh, instrumentation effect. It could be that the measuring changes from volume of dairy products to measuring the weight of dairy products. So these are 7 factors that can influence the causality of an experiment, which we have to be conscious in while designing and conducting an experiment.